Welcome back. And next up is Zach from Edge Impulse, another IoT veteran known from being a founder of Microbit, working at ARM, and now he's working on Edge AI. Enjoy his talk.
Hello, I'm Alan Proithis, CEO of Capstone Partners, where we accelerate connected business. With me today, I have the great pleasure of having Zach Shelby, co-founder and CEO of Edge Impulse. Zach, welcome.
Thanks, Alan. Great to be here.
We're not in Amsterdam like we were last year, having a beer, talking about the excitement of the launch of your company, but it's great we can still be together this way. So first of all, I mean, it was last year in Amsterdam, you were really just going public with what you were doing at the Edge Impulse for the first time. And it's really, I think, been an amazing year for you in a very challenging environment. So first of all, maybe you could just explain what exactly are you doing at Edge Impulse?
Yeah, well, we set out on a mission to really make machine learning a useful tool for people that create real embedded solutions like we do in the LoRaWAN community. So people that are dealing with sensor data of all kinds, including audio and computer vision, and then putting that to work in real industrial systems, right? Real asset tracking and cold chain management systems in health and agricultural solutions. So our mission is to help those engineers and developers that are boots on the ground, right? Making these systems, getting them to market, help them make use of machine learning as part of their toolkit.
It's fascinating to me because, you know, since IoT has the word things in it, people get a little focused on the things rather than what they enable you to do with the data that come. So maybe help me understand why edge machine learning is important, because I'm reminded of the old Silicon Valley joke of the difference between machine learning and AI, that machine learning is written in Python and AI is written in PowerPoint. And it's nice to see someone who's doing real things with machine learning. So why is it important and how is it different than other things that are being done?
And I'll pick up on your joke, right? If you think about embedded machine learning, that's when we do CMath, and machine learning is written in Python. So that'll give you an idea of the kind of the level of small and the level of optimized that we have to work in order to make machine learning part of these solutions. But stepping back, right? What this really means for people that are working on solutions is that we have the opportunity to start to use data to drive our algorithm work. And that's something we've never had before in our toolkit as signal processing experts, as IoT system people, as web designers and system designers, as scientists, right, and domain experts. We've never been able to use data to really drive algorithm design. And that's how I think about machine learning, right? Machine learning gives us the opportunity to take expert data from real sensors and real environments, the customer environments, right, in the field, and use that to drive very sophisticated algorithms that can detect patterns that we were never able to detect before, or to configure sensors to do things that we weren't able to configure before at such a level of personalization, right, for that customer, right, at that facility with this machine, right, in this scenario. We were never able to do that. We were at the best kind of able to configure something that was generic, or maybe something on kind of a per customer basis. So machine learning opens up lots of new opportunities for deriving value from data and then putting it to work.
Well, it's fascinating because you still hear all the horror stories even today about how almost all the data collected, even when you connect up things in the field, really isn't acted upon. And you mentioned data-driven design. So help me understand what you mean when you say data-driven design. What exactly does that mean?
Well, when we talk about data, typically in the Internet of Things, and Alan, we go way back in IoT, and we've been there doing this. We kind of blindly collect data in IoT as if collecting data on a regular tick without knowing what we're going to do with it is kind of the goal. And so we're collecting data in IoT, but we don't really know what we're going to do with that data. There's no expert connected with it. And that data just builds up, right, over time. We build warehouses, then we build lakes, and then we drown in the lake, and we build oceans, and eventually somebody tries to dig into that data. However, that data is kind of just sampled, right? We actually don't make use of the full bandwidth of the sensors. We're not able to make use of all the real-time, dips in complex patterns because we measure the temperature once an hour, or we measure the acceleration threshold once a day. What machine learning does is that tips the entire equation over. Instead of collecting all of the data, what we do is we collect very, very, very high quality data samples at full frequency, right? The full sensor bandwidth, no filtering, no thresholding, no sampling. And we mark that with an expert. It could be an expert system. It could be another set of scientific sensors that verify the reading. It could be a clinical trial with medical devices. It could be just the engineer who's saying that when this happens, the machine broke, right?
Yeah.
When this happens, right, the machine is normal. And this is what we talk about. We talk about labeling in machine learning. Labeling is really just transferring expert knowledge and tagging it to the sensor data. And this data, these data sets that we create for machine learning, these are gold, right? They're worth their weight in gold. They're very small. Mm-hmm. They're much, much, much more highly processed, managed. They're very specific in what we're trying to do with them. And that's the kind of data that we work with when we work with machine learning. What that data helps us do is it helps us train our sets of algorithms. And not just machine learning algorithms, signal processing algorithms can be trained with new technology, classical ML techniques. And then, of course, things like deep learning are trained with this data. And that lets us match, kind of emulate what the expert would do in the field. The expert would say, this machine is failing. Our machine learning algorithm can tell us the same thing. And that's the magic of data-driven design. We can use that data to drive solving problems. And the way we talk about it is that we make use of the 99% of data that's today thrown away because we can't handle it. We don't have the bandwidth over LoRaWAN. We don't have the battery to send all that data, even if we had the bandwidth. And oftentimes we just don't have the place to put it, right? We'll run out of the world's storage space if we just sent all this raw data to the cloud. And machine learning helps solve a lot of those problems by moving the data processing right to the sensor.
Yeah, it's really fascinating because you really solve the problem of constraint in every part of the value chain by pushing it out to the edge. The other thing I have to point out is that so much talk and investment around what we call edge intelligence today, edge intelligence, is in the form of a tower guy or a fiber guy buying a data center that just happens to be closer to an end of a fiber run. What you're doing to me strikes me as almost the ultimate evolution to the extreme edge, to really push the intelligence at the very point of sensor, because you get more value by doing it like that. So fascinating stuff. Let me ask you, Zach, your company, it's amazing that, again, you had your big announcement last year in Amsterdam. We had this unprecedented year of turmoil, both good and bad, terrible things with the economy and personal disruption and COVID. But frankly, I think it showed the value of remote connectivity and a lot of the basic kind of IoT things we've been talking about for years. Maybe just with our last minute we have here, you can just talk about, what did you really see happen this year, and what do you think is going to happen in 2021?
2020 was an amazing year, right? We went in, all lights blazing, into the future in January and February. We had a tremendous launch, right? The LoRaWAN community was super, and our launch, came onto our platform, has really been enjoying working with machine learning on these embedded systems. And we've seen a bunch of great products come to market as a result of that. When the pandemic hit, we've kind of seen twofold, right? We've seen digital transformation just accelerate a lot of cases. So the entire silicon industry has come behind machine learning as the future of where silicon's going. We went from a handful of silicon vendors involved with edge AI to all of them by the end of the year. So it was a very quick change. We saw the community grow hugely. So our community went from launching to over 6,500 developers on the platform in that short 11 months since the last Things conference, 12 months. Over 10,000 projects using machine learning on real embedded targets. These are MCU targets, right?
That's amazing.
And people uploading, millions of data points every month, and working with those in real products. So So it's an amazing amount of activity. For 2021, we're going to see a little bit of backlogging. So what happened during COVID is the problem for many of us working with customers with real sensors in the field, in maritime, in warehouses, in factories, is that many people haven't been able to get to their data. And we've seen that effect with lots of customer cases that have been quite slow because of the inability to physically access places. And we expect that over the next 6 months, as vaccinations start to take effect, that we'll see a lot of those cases get unblocked. And we expect to see that for the whole community. So I think 2021 will be a transformational year as we keep on the momentum of digital transformation. Mm-hmm. And at the same time, the business cases that have been slow will start to unlock and bring value. That's going to be really interesting.
Completely agree. I think people have realized that while we are seeing a potential end to this mess we're in, we can't stop doing business because we're not sure how long it's going to take to get to the other side yet. So it's time to move on. But Zach, speaking of the other side, our time is up. But Zach Shelby, thank you so much. CEO, Edge Impulse, some incredible things you're doing there. And I think it's exactly what the industry needs. So thank you for your time.
Thank you, Alan.